Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. Okay. If you are first time viewing this channel, then I will suggest you to go through my introduction video first to understand the presentation structure of the course content. Right? Now, we are in the class of matrices. Okay, we are in the class of matrices. Before this class, we had completed the basics of the matrices. After that, we had done detailed explanation 1, which is about the addition, subtraction and multiplication. Today, we are at detailed explanation class 2. So, today we are at detailed explanation class 2 for matrices. Now, what is the content of this detailed explanation class 2? In detailed explanation class 1, I had set the roadmap that how we will look on to these matrix operations, right? So, what was our agenda? That we had divided the matrix operations in two parts. What we had done? We had divided it into two parts. What are those parts? Number 1, matrix operations applied taking two matrices or between two matrices, like addition of the two matrices, subtraction of two matrices, multiplication of two matrices. So that will in one category, and that category is explained totally in our detailed explanation class 1, right? Now, today we are at detailed explanation class 2. So there was another category explained in detailed explanation class 1, that within two matrices, okay, which we had covered in our one group. Now other group we are having, in which within a matrix is taken, and within that we are performing some operations, right? So those kind of operations we are going to discuss in detailed explanation class 2 and class 3, right? Why class 2 and class 3? Because the number of operations are very huge. It may be 7 to 8, and we can't club everything in one video, right? The length of the video will go on. So that's why what we had done, that we will discuss first 5. We will discuss first 5 in our detailed explanation class 2 and rest of the 3 in detailed explanation class 3, right? Now let's put the roadmap for today's class. Today's class, detailed explanation class 2 for matrix operations, we will discuss first 5. Now let's see what are these all 8 different type of operations which are performed within a matrix. Okay, which are performed within a matrix. First is trace. Okay, first is trace. After that, scalar multiplication. Next, conjugate. After that, row operations. After that, transpose. After that, adjoint, determinants and inverse. Okay, trace, scalar multiplication, conjugate, row operations, transpose, adjoint, determinants and inverse. By doing this, okay, by doing this all what you can say operations, we will be completing our operations class. Okay, we will be completing our operations class. Okay, so in detailed explanation class 2, we will discuss first 5. and in detailed explanation class 3 we will discuss rest 3. So I will write it down here. These 5 are discussed over here. So we will go through trace, scalar multiplication, conjugate, row operation and transpose in today's class. Adjoint, determinants and inverse, this will be continued in next detailed explanation class. The intent of the segregation is these 3 are mainly focused on how to find the inverse. Inverse is a very important operation, okay, for a matrix. So these 3 are focused on that, finding adjoint, determinant, and after that we will see how inverse will work out, right? So what was our intent now? Our intent is today we will complete these 5. So with this we had laid down the today's class, okay. Now I will rub this, but before that please like, share and subscribe if you are happy with this video content, okay. Chalo, let's move forward. Let's start with our first operation within the matrix, that is trace, okay. So as I told, these are the operations which will be conducted within the matrix. So 2 matrices are not required, right? That is what the main intent is, okay. Only one matrix, and within that what are all the things we are having, okay, what are all the things we can derive from that, okay. So see here, I had taken a 3 by 3 matrix. This I had already explained in basics class how to see the order and all, okay. So order of this matrix is 3 by 3. What makes it 3 by 3? 3 rows and 3 columns, right? 3 rows and 3 columns make it as 3 by 3. Okay. My elements are A11, A12, A13, A21, A22, A23, A31, A32, A33. This is my matrix A, right? I think no doubt till this. Now, what I will do, I had prepared one matrix with the numbers 1, 2, 3, 6, 5, 4, 7, 8, 9. Okay. We will understand what is the trace and we will perform that operation in this matrix, right? Okay, chalo, let's get started. So, trace for this, we can represent it with TR. Okay, we can represent it with TR. It is equal to sum of the diagonal elements. Okay, it is equal to sum of the diagonal elements. So TR is equal to A11 plus A22 plus A33. Are you okay with this? What are the diagonal elements now? 1, 1, 2, 2, 3, 3. Okay, A11, A22, A33 is the diagonal of this matrix. It's like a diagonal. If you take this as a rectangle, a 2-dimensional rectangle, then diagonal, this is the diagonal, right? So trace is the sum of A11 plus A22 plus A33, right? Okay, now let's put the standard practice for finding the trace. For a trace, we had earlier learned that any element can be represented in the form of Aij. Any element can be represented in the form of Aij, where A is a matrix. Now we have to define the number of rows and number of columns. So I will define rows by I, columns by j, equal to, it will start from 1, here it will start from 1, it will move to n and j will move to n. Okay, it is a square matrix, so we will discuss the types of the matrices in our later classes, later detailed explanation classes, but just make here that this is how the sum of all elements are represented. Okay, this is how the sum of all elements are represented, but this trace is the sum of diagonal elements, right? It's not the sum of all elements. So we will put a condition here that I is equal to j. We will put a condition here that I is equal to j. Why? How we are putting the condition? We can see that it is a11, a22, a33. 1 is replaced with I, j is replaced with 1 is replaced with j also. Okay, so here I and j are equal. In this also I and j are equal, and last term also I and j are equal. So what we understand, that diagonal elements will have I and j equal. Okay, diagonal element, this diagonal, okay, not this diagonal. We will discuss this diagonals also in our one of the detailed explanation classes, but this diagonal starting from this point to this point. Okay, so a11, a22, a33, we can see that value of I and j are same. So we had put a condition here where I is equal to j. Though, so we will come up with a conclusion now that trace is the sum of the diagonal elements. Okay, sum of the diagonal elements. Now let's go into this matrix and find the trace of this. So what will be the diagonal elements for this? With this definition, so with I equal to j, we are getting a11, a22, a33, right? So 1, 5, 9. So trace for this will be 1 plus 5 plus 9, which is equal to 15, which is equal to 15. So this is how a trace can be found. So I repeat, trace is sum of the diagonal elements for which I is equal to j. Okay, this completes trace. Now let's move on to our next section. Move to the next section, scalar multiplication. Now, what is scalar? Scalar is some number. Okay, any number can be quoted as a scalar. Okay, now this is a matrix. So we will follow the same theme for our operations, that we will take one matrix in the form of a11, a12, a13, like that. Okay, and after that we will take one problem and we will see how we can do that operation. Okay, so for scalar multiplication, once we multiply a scalar with the matrix, so I will represent my scalar with k. I represent my scalar with k. What is the k? K is a scalar which can be any number, right? I repeat, scalar can be any number. Okay, scalar can be any number into a. This is the scalar multiplication, k into matrix A. This is equal to k into a I j. Okay, which is equal to k into a I j. Right? Now, how to cover the entire matrix where a I j represent the each element? So how we will cover the entire matrix? So to covering the entire matrix, for I is equal to, or we can write it as I is greater than or equal to 1 and lesser than or equal to m, and for j is equal to 1 to n. Okay, I is from 1 to m and j is equal to 1 to n. So the scalar multiplication is multiplication of a number with all its element. I will take a matrix same 1 2 3 6 5 4 7, 8, 9. Okay, 1, 2, 3, 6, 5, 4, 7, 8, 9. I will take a scalar k equal to 2 now. Okay, so as per this, it should be 2 into a11. For I is equal to 1, j is equal to 1, it is a11, right? So a11, a12, a13 all multiplied with 2, 2, 2. So what will be my resultant matrix? So let this space is not sufficient to express it. I will write it here. K into A will be, first 1 multiplied with 2, it's 2, 2 multiplied with 2, 4, 3 multiplied with 2, 6, 12, 10, 8, 14, 16, 18. This will be my resultant matrix. Okay. So what is my scalar multiplication? Scalar multiplication is the product of each element a11, a12, a13, a21, a22, a23, a31, a32, a33. So each element of the matrix with a number. That number is known as scalar. Okay. Now let's move on to the next section. In this section, we will discuss about conjugate. Okay, we will discuss about conjugate. So this is my matrix A, which are elements are A11, A12, A13, A21, A22, A33 and A31, A32, A33. Now, this is what my example is. I am taking this as my example over here. Here you can see there are symbols of I. This symbol is nothing but it's for an imaginary number. Okay. To understand what the imaginary number is, please visit to my complex number sections, complex number videos. Okay. You will be able to find what an imaginary number is. But for this instant, I will go through you what an imaginary thing is for a short time. Okay, such that this section should run. So my imaginary number is root of -1. My imaginary number is root of -1. Till your lower classes, what we study, that if something is negative, we can't take a square root, like root of -2, root of -3, root of -4. So this is what we had developed our thinking till our lower classes. Now, once we move on further, we will learn that how a negative thing can be represented. Like suppose -2b can be represented as -1 into 2. So 2 is a positive, it can be represented in a root, right? It can be represented in a root. Now what to do with -1? So root of -1, which is left off, we will denote it with I. And wherever we will see this root of -1, we will put I over there. So I is a replacement of root of -1 for all the negative square roots. Okay. So this is the whole intent. We will put I. For the further details, you go to just my complex number sections. Okay. So when we will get this I, you might have gone through one formula of Sridharacharya, which is finding the roots. Okay, finding the roots of a quadratic equation, which gives -b plus or minus root of b square minus 4ac by 2a. b square minus 4ac by 2a. Okay, root of b square minus 4ac by 2a. So b square minus 4ac, there are chances that it can be negative. In that case, we will have a square root of negative. Okay, so what we are having from Sridharacharya formula's roots are minus b plus or minus root of b square minus 4ac by 2a. Okay, so minus b is there plus root is there. So that means there is one part which is real number, and there is one part which is an imaginary. Okay, if b square minus 4ac will become negative, then only it will become imaginary. Okay, so there is one part which is real, there is one part which is imaginary. So a number is a root or a number, whichever is derived from our quadratic equation, is expressed in the form of a real number and imaginary number. Okay, so a number is expressed in the combination of real and imaginary both. So this combination is termed as a complex numbers. Okay, now you go through my complex number classes. So what I told, that my any aij element will be represented by aij plus I into bij. Okay, this is aij plus I into bij. So this I is root of minus 1 and this ij are the row and column number of what you can say, that element. Okay, so all the numbers in a complex form, all the elements in a matrix in the complex form can be represented like this. So I told a number will have a real part, a complex number will have a real part and it will have an imaginary part. So A is real part over here and B is the imaginary part. So like this, suppose I will take 2 plus 5i here. 2 plus 5i, real part is 2, imaginary part is 5, right? Okay. Now let's understand what the conjugate is. Conjugate is if real part and imaginary part is combined with positive, then if we go for a conjugate, this will become negative. If real part and imaginary part is combined with a subtraction, then it will become addition. It will become positive. This is what my conjugate is. So how the conjugate is represented? A conjugate is represented by aij bar. Okay, conjugate is represented by aij bar. So this bar will show that we are doing a conjugate of a complex number. So complex number conjugate will be here aij minus I into bij. Positive became negative. If it was a negative, then it will become positive. So this is what a conjugate means. Now conjugate has a symbol that we should represent it with bar. Now take this example. We will take this example and we will find what our conjugate is. So conjugate is represented by bar. So conjugate of this A matrix is represented by A bar. Conjugate of this A matrix is represented by this A bar. Now let's move forward. First element, we have to make a conjugate. So once you put A bar, it will become A11 bar, A12 bar, A13 bar, A21 bar, A22 bar, A23 bar, A31 bar, A32 bar and A33 bar. Each element, this bar is with each elements also. Okay, so once you do bar of all these elements, so you have the same technique that you have to convert this plus to minus. Then you will get the conjugate of the matrix. That's it. Okay, so conjugate will be first element is 2 plus 5i. It will become 2 minus 5i. Next element is 3 minus I. It will become 3 plus I. Next element is 7. It's not having a imaginary part. Conjugate will be 7 because it is 7 plus 0i. So 7 plus 0i, if you take conjugate, it will be 7 minus 0i. So 0i is 0, so it is 7 only. So it is 7, right? Similarly, in this minus 2i. Now minus 2i can be represented as, it is not having a real part. So we will put as 0 minus 2i. 0 minus 2i. If you take conjugate, then it will become 0 plus 2i. Okay, 0 plus 2i. So it will become 2i. So 6 plus I, no confusion. It will be 6 minus I. 7 minus 5i, it will become 7 plus 5i. 1 minus I, it will become 1 plus I. 3 will become 3. 6i will become minus 6i. Let me check. 2 minus 5i, 3 plus I, 7, 2i, 6 minus I, 7 plus 5i, 1 plus I, 3 minus 6i. Done. Right? So this is how we are going to find the conjugate. Okay? What are the uses of the conjugate? Why we are doing? Please go through my complex number part. Okay. So I will repeat. Conjugate is found for a imaginary numbers. Imaginary number is represented in the form of a plus ib. So conjugate of a imaginary number a plus ib is a minus ib, or conjugate of a minus ib is a plus ib. Okay, are you getting it? Okay, now let's move forward to my next section. Let's start with our next section, which is row operations, right? So a matrix represented like this, its elements are a11, a12, a13, a21, a22, a23 and a31, a32, a33. Okay, this is the known story. Now what are the rows in this matrix? We had discussed in basic class. This is my first row, this is my second row, and this is my third row. Okay, this is my first row, second row, and this is my third row. Now what we have to do is, as the name suggests, it is a row operations. We have to perform operations between rows. Okay, we have to perform operation between the rows. Now while performing operation between the rows, we had classified mainly in three categories of operations. One operation, interchanging of the rows. This is my first operation. So let me put it as number it 1, 2 and 3. These are the three main operations for row operations. Okay, you can come up with many. We will discuss it later, but these are the three main operations. First is Ri and this is Rj. Okay, please put concentration. It is I and it is J. That means two different rows. Okay, so R1, R2, if we will take two rows, then R1 can substitute R2 and R2 can substitute R1. R1 can substitute R2 and R2 can substitute R1, like that. Okay, so this is what is the first row operation. We will perform this operation on this matrix also. Okay, we will see how it is applicable to the example. Okay, with the example. Now second is Ri to Kri. That means in the same row. If R1 is there, entire R1 is multiplied with a number, okay, which is a K. It can be 2, it can be 3, anything. Okay, so a number multiplied to entire row. This is one row operation. Another row operation is Ri is Ri plus K into Rj. Ri tends to Ri plus K into Rj. Now here suppose my I is 2 and J is 3, then R2 tends to R2 plus, suppose K is 2, then 2 into R3. Okay, R2 tends to R2 plus 2 into R3. So what we will do? We will multiply R3 with 2 and we will sum it to the R2 elements, corresponding R2 elements. Okay, are you getting it? Okay, so these are the 3 operations. Now if you want to do further, you can put it as L into Ri plus K into Rj. Ri tends to. It can also happen. First you do Ri multiply with L, and after that you with L into Ri you again do this operation. So there are many numbers which number of row operations which can be possible, but all can be summed up in these 3. Okay, now let's see the example now how we can do. So let's go with the first tells Ri and Rj substitution with each other. So here it's Ri, it's Rj suppose. So my Ri is 1, I is 1 and J is 2. So if you just interchange these 2 rows, I mean 1 is substituted with 2 and 2 is substituted with 1, then it will become 6, 5, 4, 1, 2, 3, 7, 8, 9. Okay, 6, 5, 4, 1, 2, 3, 7, 8, 9. So what this operation is mine? This is my first operation, which is Ri is interchanged with Rj. Done. So this is my first operation. So what we had done? We had interchanged R1 and R2. Now let's go to next operation. So my next operation is second one, which is Ri is K Ri. So what we will do? We will take K equal to 2 and we will take I as row 2. That means I value is 2. So in second row we will perform the operation. So once we do second one, then we will get 1, 2, 3, 12, 10, 8, 7, 8, 9. Okay, 1, 2, 3, 12, 10, 8 and 7, 8, 9. What we had done? We had taken K equal to 2 and I equal to 2. So in second row we had multiplied with 2 to all elements. Then it had become 12, 10 and 8. My second row had become. So this is my second operation where Ri is K Ri. Done. So this completes my second operation. Now I repeat, it is second row multiplied with 2. So it will be 6 will become 2, 12, 5 will become 10 and 4 will become 8. Okay, now let's move on to our third. Third is Ri tends to Ri plus K into Rj. So I will take my K as 2, I as 2 and J as 1. Okay, K as 2, I as 2 and J as 1. That means R2 tends to R2 plus K R1, which is R2 plus 2R1, right? So I will write it here. So for this problem it will become R2 tends to R2 plus 2 into R1. So what matrix we will come up with? We will come up with this row operation we will come up with R2 plus 2R1. So 6 plus 2. So first row we are not doing anything because this is all operation on second row. So first row will be same. So it will be 1, 2, 3. Right? What is going to change? Change will be on R2. Now once the change will be on R2, so what change is that R2? R2 plus 2 into R1. So 6 plus 2 into 1, 8. 5 plus 2 into 2, 9. 4 plus 2 into 3, 10. Then R3 will be same because we are not doing any operation on R3. So this will be my row. After row operation, this will be my matrix. Okay, this will be my matrix. This completes our third operation. Okay, which is Ri tends to Ri plus K into Rj. Okay, this is I. Ri plus K into Rj. Okay. Now let us sum up what we had done. We had done here three operations. We had learned three types of operations which can be performed in the rows. One is interchangeable. Second one is product. Third one is product plus sum between two rows. Okay, this is what we had done in this section. Okay, same operations can be performed on columns also. Okay, so you can do the same thing for columns as well, that is columns operation. Okay, now let's move forward to another section. Chalo. Now let's get started with the transpose. What is the transpose of a matrix? If some matrix is there, if I told we had transposed that matrix, then what does it mean? Now a matrix, it's the same story, that matrix is represented in the form of A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so each element is represented in the form of Aij. A, I, J, where I is the row number and J is the column number, right? Now, if I perform the transpose on this matrix, then I will represent Aij with AT. Like we had given bar for a conjugate. Okay, we had seen earlier section that bar is for conjugate. Like that, we have to represent it with AT. In some books or in some literature, it is mentioned with A dash as well. This is a dash, A dash as well. Both of them are okay. Okay, both of them are okay. Now, what will be my transpose? My transpose, my Aij, after performing a transpose, will become Aji. Aji. Okay, after performing the transpose, Ij will become Ji. That means here 1 2 is there, it will become 2 1. Here 2 1 is there, it will become 1 2. I will become J and J will become I. Here 3 1, it will become 1 3. Here 1 3, it will become 3 1. Here it's 2 3. Here it is 3 2. Okay. Now, what about the diagonal elements? A11, A22, A33, it will remain as is because here I equal to J, right? So transpose will not affect the diagonal elements. Okay. Chalo. So I will repeat. Transpose of an matrix Aij is Aj I. It's Aj I. Okay. Now let's perform the transpose on this matrix. In this matrix, once we perform A transpose, it will be 1. First element will be 1. Here, this is A12, so it will be replaced with A21. So it is 6. It is A13, this is A13, it will be replaced with A31, so which is 7. Here A21 which will be replaced with A12. So it is 2. 5 is a diagonal element. It will be unchanged. After that, it's A32. It will be replaced with A23. So here it will become 8. Now this is A31. It will be replaced with A13. A13 is 3 here. It will become 3. This is A32. It will be replaced with A23, which is 4. And this is A33. It will be A33 because it's a diagonal element and it's not affected. So this will be the transpose of the matrix A. Okay. So just the address of the elements are interchanged. That means I and j is the address of the element. Those I and j are interchanged. J will become I and I will become j. A12 became A21, A13 became A31, A23 became A32, A32 became A23. So this is what is happening in transpose. So how to find the transpose of a matrix? If someone told if A is this matrix and you have to find the transpose, then this will be my transpose. Okay. This completes the transpose. And this ends today's detailed explanation class as well. In next class, we will look on to the further operations which are adjoint, determinants and inverse. Okay, adjoint, determinants and inverse. Okay, if you are happy with the content, please press like, share and subscribe. For the further operations, stay connected. Thank you.